Good morning. Welcome to this lecture. We continue with factor analysis. Today we discuss types of models and key questions. We discuss exploratory as well as confirmatory factor models, loading matrix, communalities, specific variance with examples. Let us see the next. We are saying the types of factor model. Types. One is exploratory factor model, another one is confirmatory factor model. Okay, exploratory and confirmatory factor model. What is exploratory and what is confirmatory? What is the difference between these two? See, in the first case, we are saying that x minus mu equal to lambda a plus delta. Here we have taken all x and all f connected together because of this delta matrix lambda, this capital lambda matrix. Because of this capital lambda matrix we have connected both. That means what I mean to say, what I am trying to say, that it is something like this. I have f1 f2 to fm and I have x1 x2 to xp, and what we are trying to say that each one of x is dependent on f, all f. I do not know exactly which are the x values or which are the x variables that are basically coming out of the f, which of the f's, I do not know. That is why what I am doing, I am allowing all the full sets of relationships here first hand. And what you are saying that okay, this is my observed variable structure, and you find out as many factors as possible, and then you say that okay, what is this number of factors and what are those the factors that are linked to what type of variables. Under this condition you are exploring about the possibility of hidden factors. That is why it is exploratory factor analysis. So, here also it will be linked, this also will be linked to. So, everything is linked to, I think this already done. Getting me? Now, confirmatory factor analysis is different. What is that? There you say that f1, f2, suppose m factors are there, but you clearly know what are the x1, x2, maybe x3, what are the variables x5, x6. So, let it be x p minus 2, x p minus 1 and x p. You know clearly, you know that 3 variables are because of factor 1, then another 2 manifest variable because of factor 2, this variable because of factor m. So, well in advance, because of your research work, your literature review and survey, all those things, you know which are the manifest variable representing what type of which factor. So, essentially what is happening here, so f1 to all other these variables, the connectivity is not required, the relationship it is not required, it is coming from here only. So, this type of factor analysis, the second this type of factor analysis is confirmatory. Why it is confirmatory? The reason is you are saying that there are, suppose few manifest variables, let it be 3 or 5 related to f1, there are some other manifest variables related to f2, and you want to confirm whether you are correct or wrong. This is your hypothesis, let it be that the first factor maybe something, let it be the supply chain coordination. So, there are certain indicators you are finding out, and you are saying these indicators are measuring supply chain coordination, these indicators are measuring something else like this. Then through statistical route you are confirming that whether what you have assumed or what you have hypothesized, what you have proposed, they are correct or false. That is your confirmatory factor analysis. Okay. So, we will stick to exploratory factor analysis now. Then I want to understand the purpose of exploratory factor analysis. Correct? What is first question in factor analysis with respect to the examples given to you? So, I think around 7-8 examples we have discussed. My question is, what is common in the examples given above? The variables to be measured are unobservable, you have seen that, hidden or latent and known as construct or factors, we have discussed. They all manifest some symptoms like in terms of x. So, this is f, this one is x. Factor analysis quantifies those construct or factors with the help of manifest variable. That is the first thing what we are doing in exploratory as well as in confirmatory also you will be doing the same thing. So, this is the illustration. Now, key question 2. I have a p number of variables, that means p information, p dimensional information base. I do not want this much of information. What I want the reduced information. See, if I require to know 2 dimensions only, then I take decision, I act, I control system, all things will be much easier if there are 5 different dimensions compared to that. What will happen? Suppose you think of a pointer, what we used to have. In this pointer, suppose there are 3 buttons, one button to just point the lecture, the sentence word, another one is just from you just scroll from one slide to another slide, the third one is the switch off, this type of things are there. Okay. So, I must know these three types information is known to me and I will do. Now, suppose there you instead of these 3 that n number of informations are available, and second thing is that if you require to go for slide change, you also require to do something else before, that is dependent things are there also. So, then what will happen? You will be confused. The same thing will happen if. So, that is why what we are saying, the lesser the information content, the better is the design. That means, we want one inference system or one decision support system where our information will be at the reduced dimensions. So, factor analysis also do this, perform this one. And what is information in factor in your data set? That is the covariance matrix. So, factor analysis uses the covariance matrix. So, the purpose of factor analysis is to describe, if possible, the covariance relationship among many variables in terms of a few underlying and but observable random quantities called factors. That is the purpose. So, we are now in a position that we know what is construct or factor, what are manifest variables, and what is the exploratory factor model, and what are the different assumptions related to this factor model. Okay. So, now the crux of the matter is variability explanation. We are saying that information is covariance of x, which is sigma. So, you are creating a factor model which is x minus mu equal to lambda f plus delta, we are using lambda f plus delta, Getting me? This is your factor model. I want to know that what is the variability you are able to explain using this model. Whose variability? Variability of x. What is that? That is the covariance of x, p cross p. So, if I want to understand covariance, can I not write like this? Covariance of x equal to expected value of x minus mu transpose. We have seen earlier also. So, that means this quantity we can write like this, x minus mu. Suppose if I say this is my equation 1, from equation 1 I can write lambda f plus delta into lambda f plus delta transpose. X minus mu equal to lambda f plus delta, lambda minus delta transpose. So, I am writing like this, lambda f into this one. So, this one will be f transpose lambda transpose plus lambda f delta transpose plus delta f transpose lambda transpose plus delta transpose. Okay. Now, that capital lambda is the regression like constants you have seen earlier. So, this constant will come. So, lambda expected value of f transpose capital lambda transpose plus lambda expected value of f delta transpose plus expected value of delta f transpose lambda transpose plus expected value of delta transpose. Now, you have to see the covariance this assumptions. Okay. So, I am putting the assumptions parallelly here. So, what we say assumption is expected value of f transpose is I. So, I will put like this lambda I lambda transpose plus lambda expected value of f and delta, where what we have written related to f and delta, this one, this is 0. So, this into 0. So, similarly, this 0 into delta lambda capital lambda transpose plus what is the covariance of delta, that is expected value of delta transpose. So, this one. So, this is psi. So, then what is happening to the resultant matrix now? Capital lambda I lambda is lambda transpose plus this. What is this? This is your sigma value. Covariance of x is capital sigma. This is equation number 2, and this is the variability explanation point of view this equation. So, that means if you know this lambda capital lambda and then psi, you know this. Getting me? What is this capital lambda here? This one is nothing but, can you remember what we have given? Lambda 1 f1, lambda 1 2 f2, like this lambda 1 m fm, lambda 2 1 f1, lambda 2 2 f2, lambda 2 m fm, like this. So, this lambda part I am writing now. So, lambda p1, lambda p2, lambda pm. This one is P cross M matrix. What is this lambdas basically? suppose this one, the loadings, they are termed as. So, if you take a general formula like xj, what we have written, lambda j 1 1 1 2 1 m, yes, j1 x1 lambda j2 x2, like this. If I write lambda jk, your jk, sorry, lambda xj, you write lambda j1 f1 lambda j2 f2 lambda jk fk. So, similarly lambda your jm fm plus delta j. This is the original equation we have, lambda j1 f1 like this. So, see what is happening here, this general one is lambda jk, this is the general loading. Okay. So, it will be for j equal to 1 to p, k equal to 1 to m. So, this one is known as loading matrix. Loading matrix means this is usually factor loading matrix, and each lambda jk, they are the loading of kth factor on jth variable, x variable. Okay. This one is lambda jk is known as loading of kth factor on jth x. Correct. Now, then what is your lambda transpose? So, if you write down this, you have to write down lambda 1 1 lambda 1 2 lambda 1 m 2 1 2 2 2 m p 1 p 2 p m, then transpose 1 1 1 2 1 m 2 1 2 2 2 m p 1 p 2 p m. This is your p cross 1, this is now m cross p, and you must get p cross p, because this p cross m, p and m cross p. Okay. So, if you just multiply the matrix, lambda 1 1 into lambda 1 1, lambda 1 2 into lambda 1 2, lambda 1 m into lambda 1 m. What is changing here? This 1 remain constant, this 1, but let k I am giving, k is basically 1 to m, the factor is changing, k equal to 1 to m and this square, lambda 1 1 square plus lambda 1 2 square plus lambda 1 m square, like this. Plus, then second one will be again k equal to 1 to m, you see lambda 1 1 to 1 m and 2 1 to 2 m. So, that means lambda 1 k lambda 2 k, the covariance part is coming here. So, same manner k equal to 1 to m lambda 1 k and lambda, no, k is 1 to m, now it is 1, then 1 2, then 1 p, this is p cross p matrix. Lambda 1 k lambda p k. Okay. Lambda this this row vis-a-vis this column. This is coming here. So, same manner now it will be a symmetric matrix k equal to 1 to m lambda 1 k lambda 2 k. This will be lambda 2 k square k equal to 1 to m. Same manner lambda 2 k lambda p k k equal to 1 to m. In the same way it will come k equal to 1 to m lambda 1 k lambda p k. Same manner you go, it will be lambda p k square k equal to 1 to m. This will be p cross p. Okay. So, this diagonal element is the variance component, off diagonal element is the covariance component, and this diagonal element relates to each of the variables also. Then if I write down further, I can straightway write that lambda lambda transform plus psi. If I write, this is nothing but, I am not writing the off diagonal element now, only diagonal element I am writing 1 k square k equal to 1 to m lambda 2 k square k equal to 1 to m lambda k equal to 1 to m p k square. Then of diagonal elements already you have written with lambda 1 k, that lambda k and something like this, already you have written this, plus our psi is psi 1 1 0 0 0 psi 2 2 0. So, like this 0 0 psi p p. So, this is what is your sigma. So, if I write this sigma in the same manner the way you have written in matrix, so that means this one will be sigma 1 1 sigma 1 2 sigma 1 p, then sigma 1 2 sigma 1 p, now sigma 2 2 sigma p p. This sigma is like this. So, this is p cross p. Then if you compare this versus this diagonal element, what you will get? Sigma 1 1 equal to sum total of lambda 1 k square k equal to 1 to m, correct, plus psi 1 1, yes or no? So, similarly you will be getting lambda sigma 2 2 equal to k equal to 1 to m lambda 2 k square plus psi 2 2. So, in the same manner, if I want to understand here, suppose j j, let it be write down j j, because we are interested in the variance components j j. So, what will happen here then? K equal to 1 to m lambda j k square plus psi j j. Then actually what is this? See, now try to understand the variability part. Our variable is xj in this equation, corresponding variable is xj. It has sigma jj, that is the total variability. So, I can say this total is sigma jj. Now, this is divided into two parts. If I say this is the case where this portion k equal to 1 to m lambda j square and this portion is phi jj. So, what I am trying to say then, that sigma jj is partitioned into two parts, correct. This one this one is what? Lambda j is equal, you see you are extracting m factors and lambda j1 square plus lambda j2 square plus lambda j3 square, like this up to lambda j m square. So, this is the contribution by the m common factors. This is the contribution by the m common factors, and this psi jj is something which is not contributed by the common factors. That is why this one is known as communality, and we denote it in terms of h j square, communality, and this one is unique to x j. The common factors are not able to explain this much of variability. This is unexplained. This one is unexplained one. This is explained by the common factor. This is unexplained. So, it is we can say unique. We say unique or specific variance of x j. Okay, so it can be like this. So, unique and specific, again some you can argue that this portion which is related to x j, precisely related to x j plus something which are, because you have taken m factors and some other maybe variable correlation, some other variable you have not considered, your data collection, many things. So, error also may be included here. But in factor analytics analysis term, we say usually we denote like this: the variability of x j is because of the communality and because of the uniqueness of that variable. Correct. So, what do you want then? You definitely want to maximize the communality.
The first part represents variability with other components.
Common factors contributing towards explaining the observed variables variability. So, that means what is the variance part from the, what is the contribution for the first factor? Lambda 1 square. What is the contribution towards variability to the second factor? That is what we are saying, that second factor lambda 1, that if it is variable x j, then j 1 square, if then j 2 square, j 3 square, lambda, that all lambda square. These are contribution from each of the factors in explaining to the variability of the x j, that variable, and something you will not be able to explain. You can explain if you suppose you extract p factors out of p x variables, okay, everything will come under this communality, but that is not the purpose of factor analysis. Factor analysis one hand wants to reduce the dimensions, other hand it will do in such a manner that the factors can be linked with the original variables, and naming of factors can be possible. Getting me? Now, with respect to another one concept here, what will be the covariance of x and f? X is your original variable, f is the factor. Okay. So, your expected value of x minus mu and then f minus expected value of f transpose, that will be the case. Expected value of f is what? 0. So, ultimately this is expected value of x minus mu f transpose. Now, what is x minus mu? X minus mu is lambda f plus delta. So, then x minus mu f transpose is lambda F delta F transpose. So, lambda F delta plus delta F delta. Now, if I take expected value of all those things, so ultimately this equal to expected value of this equal to expected value of this, expected value of this. It will delta will lambda will come, expected value of F transpose plus this one will be 0. Now, F transpose expected value is I loading. That loading matrix is coming into consideration. Okay. I think that we have explained the primarily the conceptual model of factor analysis. This is whatever we have discussed, it is just the conceptual model, that what is factor analysis, what is exploratory factor analysis, and how the variance of individual observed variables are partitioned into communality and specific factors. And but what is require, our definitely our next topic will be estimation.
Estimation of
Lambdas. That lambda matrix you don't know this, na? This lambda matrix is not known to you. You have to estimate. So, there are different method of estimation. Okay. But I thought of giving you one example. Let us see one example here. Okay. This example with respect to the factor analysis, this one is a study conducted by Lawley and Maxwell in 1971. The purpose is to measure the general intelligence. So, for students, 220 students were considered, and the variables that were taken, these are observed variables. So, these are, suppose the first one Gaelic, English, history, these are basically the verbal subjects, and arithmetic, algebra and geometry, these are your mathematical subject. What happened, in order to test the general intelligence of these many students, so these 6 subject performance, that means performance of each students on these 6 subjects were what I can say obtained, and then with this data set factor analysis was conducted, and to see that whether that these 6 x variables what you are observing, they are actually 6 or these can be combined into several reduced factors, number of factors. Okay. So, that means what is happening here, that we are talking about sample, but so far what I have discussed, we have discussed for population, because we have taken mu, we have taken sigma, we talk about lambda, we talk about psi, all those things related to population. Definitely during estimation time we will see this sample part, but let us concentrate on this example now. Then the immediate step, you have to see the correlation matrix. You see, the if I go by the correlation coefficient between the variables, there are few variables point with correlation more than 0.3. For example, x1, x2 0.44, 0.41 like this. So, 0.60 is the maximum. So, from correlation matrix also you can find out certain clues that whether you go for factor analysis or not. That factorability criteria, that means the data matrix must be factorable. If you have seen in principal component analysis, I say that Bartlett's sphericity test, What we have assumed there? Bartlett Fericity test. We assume H0 that R is I and H1 are not equal to I. That means the correlation coefficient you have tested and combiningly you have tested this. Okay. So, here I think we definitely require Bartlett's Fericity test to see that whether we will go for factor analysis or not, because if there is no that not significant much correlation, what is the use? But factor analysis from correlation coefficient point of view, if there is 0.3 or more correlation coefficients, a large number of correlation coefficients having 0.3 or more, then it is recommended you can go for factor analysis and you will get certain benefits. Okay. So, we will stop now and next class I will explain the parameter estimation, basically that loading, how to estimate the loading vector, loading matrix. Okay. Thank you very much.